I gave you guys a right angled triangle, what comes to mind? Let's think about all the things that possibly would come to mind just from being given a right angled triangle. Beautiful. I see it. Thanks, Samsung. I see it. High five. High five is the first thing. Beautiful. I also saw somebody said trig ratio, trig, name them. Don't just say trig. Like, we need to bring your mind to where we need to go with these. Good. No worries, Pascal. So great to have you. Good. Don't just say that. Good. Cos, sine, and tan, or sine, cos, tan. Good. Cos, sine, and tan as well. Think of anything, guys. What we know when we look at a triangle, any triangle at all, we know that we always have an angle. Theta. What do we know about that? Good. Equals 180 degrees. Beautiful, Mirula. That's exactly what I wanted to hear. The SOHCAHTOA. Beautiful. SOHCAHTOA. What do we know every time we look for an angle? What needs to happen? Anytime we look for an angle, what needs to happen? Anybody remember? Ah, that's it. Beautiful, Tiana. That's it. Okay, good. We need to shift angle. We need to click shift in order to find the angle theta. All right. So these are all the things that come to mind. We also just need to remember, guys, for reference, this is adjacent. That is the opposite. This is the hypotenuse. Do not forget this. Okay. So we're going to be looking at all of these, but we're going to be looking at questions that are going to challenge us. Okay. They're going to challenge us. I spoke to, and for those of you who only come back from holiday just now, I'm very sorry to do this this very moment. I think Teacher Nell wasn't there either. I had a conversation with the grade 10 standard, and I asked them if they would like for us to do a few more challenging questions that are a bit more challenging. And everybody said, yes, ma'am, bring it on. Okay. No worries, no much grief. Okay. And everybody said, yes, bring on the challenge. We want the sauce. So give me a thumbs up if you guys are ready for the sauce, because it's coming today. It's coming. We're going to be on a different level of things today. Give me a thumbs up if you guys are ready. You guys are going to have to get ready for it, guys. I wish I could do that. I wish I could and hear my muscles just I don't know how the guys. Thank you. There's our first one. Hi, Jasmine. Hi, my sweetie. Excellent. All right. Okay. So today's lesson is labeled Going the Distance. It is lesson 1 of 4. Okay. It's lesson 1 of 4. And today we're going to be focusing on calculating. Okay. So we're going to look at this. All right. So we're going to have to think about all the information that we've been given here, guys. And we need to make sure that we're using it to our advantage. I use it to our advantage. And okay, we're going to use the information to our advantage, and we're going to remember all the rules that we need to know that will help us with what we've over here. Good. Now, let's read the information that we've been given over here. It says here, given a triangle ABC with line FE, okay, line FE parallel to line AB. Okay, so as soon as we hear parallel, what do we need to be thinking of that? As soon as we hear the word parallel, what do we need to think of? Ah, beautiful. Good. We need to think of fun angles. Okay. Fun angles. And for those of you who are asking, what are fun angles, ma'am? Corresponding angles, co-inferior angles, alternate angles. Okay. Those are the angles that we need to think of. Fun angles. All right. It says here BE is 3 centimeters. We see it. Good. They've given it to us. Okay. And then it says round off to 1 decimal place in each of the questions that we're about to answer. Okay, which means our calculators are going to have to come into play. We may need our calculator. Now it says, find the length of ED. ED. Exactly. All right. So before we even start, let's start by looking at how many triangles we actually have. Try and count them. I know there are a lot. I'm gonna be honest. There are a lot. No worries, Joe. Welcome. There are a lot of them. Can you count them? Have a look. Start with the big one, and then come in with the smaller ones, and then the smaller ones, and then the smaller ones. Okay. Nico, I think you may be onto something. You might have missed maybe one. I think you may have missed one. I count 6. Teacher Nels, have you counted? Do you know how many you see? No worries, Delaney. Welcome. I just see 9. Okay, I might agree with 9 actually. Good. All right. So if I look at the big one, there's the big triangle ABC. There's 1. There's 2. There's 3. Okay, that's 3. And then I can go this way. That's 4. That's 5. That's 6. The tiny little triangle in the middle, that's 7. That one over there, that's 8. No, maybe I'm not seeing the 9th one. Okay, I'm not seeing the 9th one, but I do see 8. I do see 8. Okay. Hello, Jasmine. How are we doing, class monitor? She's the class monitor now, guys.
Okay. I'm here, but the 9 triangle is where point F is and the 31 joining to point at the bottom.
Ah, beautiful. Yes, like that. Oh, thank you. I didn't actually see that. Thanks. Oh, see, this is why we need you here. Yeah, good. Thank you. Amazing. All right. Awesome. Thank you, Jasmine. Amazing stuff. Good. BEF. Oh no, not even. That's 10. I think that might even be 10. BEF. So that might just be 10 of them. You. Okay. Cool. That's a lot of triangles, by the way. All right. So now it says to us, find the length of FD. So now we need to recalibrate everything that's happening here. We need to go find FD. Let's look. FD is over here. We want to find the length FD. Now, I want you guys to note that FD is not part of a right angled triangle. Okay, FBD does not give us a right angled triangle. So in order for us to get that right angled triangle that we need, we're going to have to put together 2 other triangles that are going to give us the distance between FD. Who can figure out the 2 triangles that we need to use that will come from a right angled triangle? For the 2 triangles that are going to give us what we need. Anybody got any ideas? Okay. Somebody named user, remind us of your name again. BFD is not going to help. Okay. BFD, we need a right angled triangle. And remember, guys, okay, we need to go as far as we possibly can. Oh, it's Nico. Is it Nico? Okay. BDE, good. I agree. BDE is definitely one of them, right? BDE, good. That's going to be the one triangle we're going to use. Triangle BDE, and which other triangle? Good, that's it. And triangle BFE. BFE. Because our right angle, remember that AB is parallel to FE. And this, if this is 90 degrees, this is also going to be 90 degrees. Okay, so that is our 90-degree triangle. So triangle BDE and triangle FE. Okay, so now we need to stretch it out. We need to come up with an idea. How are we actually going to figure this out? What are we going to do? We've look at the idea that these two triangles need to work together in order to give us what we're looking for. How are we going to marry these two ideas in order to get the distance that we want? Remember, we just want this distance. Does anybody have an idea? Let's help each other out, guys. Let me see. Okay, I'm going to start us off. All right, I'm first going to go into triangle BFE. I'm going to use the big triangle. I'm going to go in triangle BFE, which is the big one. That BFE. I'm going to use triangle BFE to calculate for FE. I want FE. I want the side FE. So we need to remember, guys, that we first, number one, we need to label. Let's start by labeling. If the angle I have over here at F is 31, this side is called my what? What is this side over here? What is the side FE called in terms of my triangle? Is it my opposite, my adjacent, or my hypotenuse? This side here. The one right next to it, Helele. Good. It's called my adjacent. That side over there, at the end over there, BE, that side is called my what? On the good. That is my opposite side. Beautiful. Right? And then this side, FB over here is going to be my hypotenuse. That's the first thing we're going to do. We're going to label. Okay, check. We've labeled. The next thing I'm going to do, number 2, is I'm going to do my have versus my want. Okay. All right. What do I have? What information have I been given? Let's look at the drawing over here. What information have I been given? In that triangle. Good. They've given us the opposite. Beautiful. They've given us the opposite. And what else do we have? Angle. Beautiful. They've given us the angle, 31 degrees. Good, Pascal. The opposite is our 3 centimeters. Now, what do I want? What do I want? Good. Amazing. I want FE. Right. Nico, we're not at FD yet. I want my adjacent. Side. Good. I want this side over here because I said I'm calculating for FE. So I want FE. That's my goal right now. Get the length of FE. Right. So I can then look at what I have, and I'm going to use what I know from my trig ratio. Which trig ratio uses the opposite and the adjacent? Between the saw, the car, and the tower. Which one are we going to use here? Beautiful. We're going to use the tan. Good. So I can say that tan of theta is equal to opposite over adjacent. Right. That means that tan of 31 degrees is equal to opposite, which is 3 centimeters, over adjacent, which we don't know. We know that it's FE. Okay. Now I need to make FE the subject of the formula. What is my first move? What can I do? Yes, Tiana.
Ma'am. So we can times FE by 31 degrees.
Beautiful, yes. So we can take the FE over to that side and multiply by it. Or I'm just going to multiply by FE on both sides. Okay, so those two will cancel. And now I have, don't go away, Tiana. FE tan of 31 is equal to 3. Now I want FE on its own. What's my next step?
Then can we divide it by, now we divide 10 by the 3. Am I speaking right? Or the 3 divided by 10.
Good. We're going to divide by the tan 31. Remember, I want FE on its own, right? So I'm going to divide both sides by tan 31. Right? And those two will cancel. Now I have FE is equal to tan of 31. Oh, 3 over tan of 31. 3 over tan of 31. Punch that into your calculator. Give us the answer, Tiana. For one decimal place.
1 decimal place is
Mhm.
is it gonna be is I know there's a 4 there, but after the comma I see 2 9s. So
Okay. So we would have to say in this case, because it's 4,99, yes?
yes.
Good. So we're going to say, we're going to say, because the 9 will change the other one, will change the other one. So we'll say, amazing. Now, before you go, Diana, I'm going to inform you that I have now given us the length of FE. We now know that FE is 5 centimeters long. What do you think we're going to calculate for next? If we know that the distance from FE is 5 centimeters, and we still want the distance from FD, we want that distance. What do you think is the next distance that we're going to know?
So I don't know, man.
Think about it. If I want FD and I'm giving you FE,
Do you think we're gonna divide it? But it don't look like it's the same length.
it's not the same length. It's not, Pascal. We cannot do that. It's not part of the side. But look at what Amate has said. Think about what Amate has said.
DE.
Amate says we must look for DE. We must look for this distance. Why did Amate say we need to look for that distance?
Isn't it together? I don't know.
Because FD plus DE is equal to FE. And if we have the 1, can we not just minus the 1 from the other?
Yeah.
You kind of see where I'm going with this. Let me break it down.
Kind of.
Let me break it down. Okay. I'll break it down. If I have these two chunks. Right? And I now tell you that this is 9 centimeters. Then I say that this section over here is 5 centimeters. How long is this section going to be?
4 centimeters.
4 centimeters. Right. Good. Okay. So that's basically what we do. Now, at the moment, I am saying that I want this small section. I want this section. I want FE. But I've given you that FE is 5 centimeters. So from here to there is 5 centimeters. Let me write it.
So if we get this one, if we get the one that's the other side, then if we separate it.
If we get DE, then what can we do from?
We can subtract it.
Beautiful. You see it now. Does that make sense? Okay,
Yeah.
good. So let's go back to our drawing very quickly. Everybody else, give me a thumbs up if you're getting where we're going with this question. Okay, I've given you that FE from here to here is 5 centimeters, correct?
Yes.
I want this tiny piece over here. How am I going to figure out this tiny piece? What other piece do I need to figure out?
DE.
Okay. Do you see it now?
Yes, ma'am.
Beautiful. Okay, amazing. Okay, I'm just using it to help everybody else kind of understand where we're going with this. Yes, Jasmine. Okay.
So if you look at the triangle from as BDC, right? Wouldn't that line be like a perpendicular line across?
Not particularly. Okay, because they haven't told us that. Okay, So we don't assume anything unless they explicitly. Okay. We don't just assume that it's 90 degrees because it looks 90 degrees. What if it's 89 degrees? What if it's 91 degrees? We can't make that assumption. Okay.
Right.
So we need to work with what people. Okay. Does that make sense? Okay, cool. So now I want to calculate DE. I want to calculate the distance of DE because then I'm just going to subtract one from the other. Which triangle am I going to be working in now? If I want to calculate for DE, which triangle am I going to work in, Namisile?
The triangle BDE.
Beautiful. We're going to do DE. Do you want to help me out with this question? I think
Yeah.
it's quite nice now that we know what we're doing. Yes. Okay. Let's do this one together. All right. What do we have?
We have the opposite, which is 3, and then we have the angle, which is 47.
Beautiful. 47 degrees. What do we want?
We want the adjacent DE.
Beautiful. Ah, wonderful. And which trig ratio are we going to use?
10.
10. Good. So we're going to get 10 of theta. Good. All right. Give it to me in
Yes.
equation. Give it to me as an equation.
The equation is 10 of 47 is equals to 3 over DE.
Beautiful. DE. What's my next step?
And then we multiply on both sides. And then DE is going to cancel each other. Then it's going to be DE 1047 is equals to 3. Then you divide by 1047 on both sides. And then it's going to be DE is equals to 3 over 1047, which is DE is 2.8 centimeters.
Oh my gosh, this is oh my God. Okay, yeah, I couldn't even keep up with the writing. You were so fast.
Oh, sorry.
Yo, 2.8 centimeters. Beautiful. Ah,
And then
don't go away. Finish up fast.
FE, yeah, you say 5, 5 minus 2.8 minus 2.8 is equals to 2.2 centimeters. So FE is 2.2 centimeters.
Amazing. I love it. Ah, well done. Sure. Like just wow, flowers everywhere. Well done. Yo. Guys, like my finger I was writing there. I was writing. Yo, Namisile, well done. Amazing stuff. Yo, I was struggling to keep up there. Guys, I know. Okay. On a scale of 1 to 10, 1 being easy, 10 being difficult, how did you guys find that? Let me know in the chat. How are we doing? Okay. I can see why it could go up to a 10. Okay. We just need to frame things in a way that, they're going to help us as we go. Okay. You're seeing a 2, I'm seeing a 7, 9.1. I do. Okay. 9.1. So it's only 0.9 easy, but that's fine as well. Okay. Okay. So the thing we're trying to do here, guys, is just put this in a frame of reference, make sure that we're looking at things in a way that will help us get where we need. Okay. Now, let's look at the next question. Okay, but these are all very challenging, guys. C means complex procedure, which means it should take us a lot of thinking to get where we need. These are those, those 4 mark, 5 mark questions that you get in any test or exam. These are the types of questions that. All right, let's look at the next question. The next question says, find the length of EC. Let's go find EC. Let's go have a look at EC, guys. EC is that section over there. Okay, so triangle are we going to find this in? If we want to calculate for EC, what triangle are we going to look in, guys? Look for the triangle that we're going to use. Okay, ABC is a little big. It's a little bit big. We'll have to split it up more than one siphelele if we use that. But I agree, DEC tends to work. DEC. But siphelele, what you've just said about triangle ABC, very, very not so important. Very, very important. Okay. I'm learning my Spanish and Italian, guys. So I'm getting it. Okay, we're going to use triangle DEC. Okay, triangle DEC. Now, I want us to look at triangle DEC and tell me, guys, what information do we have in triangle DEC? What information have they given us? We know DE. We figured out what DE is, right? We've got DE. What's missing? What's missing? By the way, because this is 90 degrees, we know that this is also 90 degrees. What is missing? Good, Tiana, excellent. We know that the angle is missing. Okay, in fact, both angles are missing. Both angles are missing. Okay, both angles are missing. We don't have this angle over here. We don't have the angle D, and we don't have the angle C. So we can't just calculate things with one side. It's not going to help us. How are we going to find any one of these angles? Bonus points for whoever can pick it up. Patu.
Hi, ma'am.
Hi, my sweetie. How are you doing?
I'm good. How are you, ma'am?
I'm excellent. So how are we going to find this angle that we're looking for?
Okay, ma'am. So we can find angle C by using triangle ABC.
I love it. I love it. Beautiful. So we're going to say in triangle ABC. How are we going to figure this one out? Go for it.
36 degrees plus 90 degrees plus angle C plus angle AC. What? Plus angle ACB. Yeah,
Good.
is equal to 180 degrees.
Beautiful. You see why it's very important for us to go back to the base, right? Angle sum and triangle.
Yes, ma'am.
Beautiful. Beautifully done. All right. Give me an answer for C.
C is equal to 54 degrees.
Beautiful. Now we have enough information, hey? We've got enough information. Marula, don't go away. I want you to actually, somebody come back with this question with me. Okay, good. We now know that we've got that. All right, Marula, let's think about what we have and what we want. Let's put this into what we have. Okay. What do we have?
We have the C angle, length of DE, and 90
Good.
degrees.
Good. So we have the length of DE, right? But in relation to our angle, what would the length of DE be?
Tan 54 equals to 2. Wait,
Yeah. Okay, so what would we call the sides 2.8? In
opposite.
relation to our angle. Good, it's the opposite side. This would be our adjacent, and that would be our
Opposite.
opposite. And what do we want?
We want EC,
Good, which is our one.
adjacent.
Beautiful. Adjacent. All right, so which trig ratio are we going to use here?
We're going to use tan.
Good. Give me an equation.
Tan 54 equals to 2.8 over EC.
Beautiful. 2.8. Next step.
EC goes on the other side.
Good. So we end up with EC and 54 is equal to 2.8. Next step.
And then we divide it by 1054.
So EC is equal to 3,8 divided by, and give me an answer, maybe. Hello,
Two.
Anna.
2.03.
2,
03.
okay.
03.
We're just going to round it up to 2 because they wanted with just one decimal place. Right.
Okay.
So we're just going to say 2 because 0.03 is just going to give us 2.0.
Hmm.
So we'll say
Okay.
beautifully done. Very, very well done, my dude. You did that spectacularly. Amazing stuff.
Thank you.
Guys, you guys, like, you're my whole life. You're my whole life. Because you guys are, I'm going to ask this question again. Okay. On a scale of 1 to 10, 1 being, I still don't understand you, ma'am. No, you're speaking Greek. 10 being, I got you, ma'am. This is kind of easy. I'm seeing where we're going with this. I can do this. Where are we? Okay. All right. Good. Getting a lot of 9s and 10s. I see those 4s. I see you, Pascal and Nkechi. It's fine. It's perfectly fine. Pascal and Offensive at 4, that's perfectly fine. We just need to remember that we need to frame the thing that we're looking for in terms of what we need. Okay, so we need to be very strategic about what it is that we're doing in order to answer these questions. That's okay, Asbonge. We're going to look at another question and we're going to see if we can put it together. Okay. Now it says here, find the length of a. Let's go to the next one. It says here, find the length of a D. I'm going to erase all of this other stuff here, the stuff in the middle, just so we're not confusing the opposites of other things with other things. All right, let's look at AD, guys. Let's have a look at AD. Okay, this is the side AD. Now, if we look at the side AD, is AD connected to any right-angled triangle? Yes or no? Is it connected to a right-angled triangle anywhere? Pascal, you say yes, you need to give me the triangle. Where is that right angle that we're looking for? Okay, ABD, yes. But if I draw out ABD, this is no longer a right-angled triangle. This becomes part of the right-angled triangle, or a small chunk of the right-angled triangle. We don't know what angle D is. We only know what angle A is. Right, we only know what angle A is. Okay, so Courtney, be very careful, my CD. Look, we don't know what this angle is. We don't know what this angle is. Okay, we only know what angle A is. So we're not even sure if this whole triangle is actually 90 degrees. There is a way for us to check. We can check, but it will take us forever to get there. There's no point in us doing that already. Right. Okay. Actually, no. Let's check, guys. Let's check. Let's do this. Somebody find me this angle. Can somebody find me the angle B over here? This is 90 degrees. And we know that this is 54 degrees. Somebody please find me the angle B, this tiny little angle over here. Is it 36 or 31? It should be 36 because this thing and this thing are parallel and these two should be corresponding angles. So this tiny little angle over here should be 36 degrees. Okay, 36 degrees. Now, if I put these two angles together, 47 degrees plus 36 degrees. Good. Yes, Tiana. Beautiful. Beautiful. That is the correct strategy. Good. Now, this angle over here becomes 83 degrees. Okay. So this triangle ADB, it's not a right angle triangle. So we can't use it. But Tiana says, we can use, let me not erase that. That's very important. 54 degrees. Tiana says, we can use the triangle ABC, and we can work it out just like we did that first question that we did. So we can work out the length of AC, and then we can also work out the length of then how are we going to find the length of AD? If we figure out what AC is and what DC is, how are we going to figure out what AD is? What can we do there? If we use adjacent angles on a straight line, we're going to get an angle. Okay, it's not going to give us the length. Good. We're going to subtract. Yes, that's it. We're going to use trig, subtract, and then we're going to get the length of each of those. Give me a thumbs up if you understand what to do. Okay. Mirula's like, no, ma'am, I'm not getting you. Okay, that's okay. Namisila, I see your hand is up, my sweetie. What's up?
Now, I wanted to try it. This.
Oh, absolutely. Okay, absolutely. Can I ask you to just
But
mute
like-
for me for 1 second? Okay.
Okay.
I just want to make sure everybody's on the same page. Okay. Don't put your hands down though, because we're going to talk through it together. Now, guys, think about this. Remember that first question we did? Let's think about that first question we did. If we remember that first question, ma'am saying, I said here, I want the length of FD. I want this length. And in order for us to get that length, we first found the length of the long one. And then we found the length of the short one. And then we said long minus short equals that. Give me a thumbs up if you remember us doing that. You remember that? Everybody with me there? Okay, cool. I'm glad everybody's with me. Now, let's think about what this needs to look like next. I now want this, I want A, B. So what I'm going to do is I'm going to work out the length of the long side, AC, and then I'm going to work out the length of BC, that section there, that short section over there. And then how will that help me get this distance? What will I do to find the distance of AD? Okay. I'm hoping we are all on the same page. Okay, we're going to use the two different triangles to figure this one out. Now, I know that the triangle that we're going to use for the long side is the big triangle. We're going to use triangle AC. What about the section DC? If we want to find DC, which triangle are we going to use? Triangle? I'll give you a hint. We just used it in the question before. Good, Asbonge. That's it. Good. We're going to use the triangle Ds. All right. Okay. I'm hoping everybody is with me. Okay. Hope everybody is with me so far. Okay. Now, let's get to work, grade 10s. All right. So, in the big triangle, let's start in triangle ABC. Okay, Namisida, are you ready, my sweetie? Let's go.
Okay.
Tell me,
So
what do you have?
in triangle APC, I used the angle 36. So we have
So we have
angle 36, and then we have the opposite, which is 5 centimeters. I added 3 centimeters and 2 centimeters.
good. 3 centimeters plus 2 centimeters is going to give us a whole of these feet. Beautiful, which is the opposite side.
Yes,
That's fine.
5 centimeters, and we
What do
want
we
the
want?
hypotenuse.
Beautiful. We want the hypotenuse.
And then
Go for it.
we are going to use sin.
Good.
So it's going to be sin 36 is equals to 5 over AC.
5 for the hypotenuse, which is AC. Next step.
Yes, and then we multiply on both sides, and then it's going to be AC sin 36 equals to 5.
Good. 18, 6 is equal to 5. Good. Next step.
And then we divide, so it's going to be sin is equals to 5 over, no, AC is equals to 5 over sin 36, which is AC is equals to 8.5 centimeters.
Beautiful. 8,5 centimeters. Oh,
And then,
very nicely done. I'm going to ask somebody else to take over the next question. Okay, I think you've done a lot. You're just
okay,
like
no problem.
a giver. Like literally, it's transparency. Beautifully done, by the way. Just amazing. I'm so happy. Like you just come in and you're just like fire, dominating. I'm loving it. Just
Thank
so
you.
boss vibe. Love it. Love
Thank you.
it. Amazing. Very well done, my sweetie. All right. I need somebody to take over from where Namisila's left us. So Namisila's given us the long side. Does anybody want to give us the short side that we need to minus? Okay. Remember the short side, we've used the triangle ABC. We now need DEC. We need to use triangle DEC to get the length of DC. Anybody want to venture to give it a try? It's not going to be that easy. It's not going to be that easy. We now want this section here. We want, yes, Mirula.
Hi. Do we
Alright, tell me.
find
Let's go.
hypotenuse of DC?
Good. We have, what do we have in that triangle?
We have adjacent and angle.
Good. We have the adjacent and the angle. What do we want?
We want DC.
Which is that?
Hmm?
In terms of this triangle. DC is our what?
Yeah.
Is it our side? Is it our adjacent side?
Oh, hypotenuse.
No, it is the hypotenuse. I know I said it for DC. But yes, we're looking for the hypotenuse. And somebody say, ma'am, can we use Python? Yes, you can use Python. I don't like to do it. Okay, finish up for me, Mirula. Go for it.
Cos 54
Good. Cos 54.
equals to 2 over DC.
Good. 2 over DC.
DC
Good.
moves to the other side.
Good.
And
Equals
then
4 is equal to 2. Therefore, DC is equal to
3.4.
good. Okay. I'm just gonna write down the step, otherwise we're gonna lose some people. Over cos 54. Therefore, DC is equal to 3, 4. Beautifully done. Amazing. Amazing stuff. Okay. So now we know that this section over here is equal to 3, 4. We know that the big section all the way from here to there is equal to 8, 5. What is the last thing we need to do? Last step we need to take. That's all. We just need to subtract big from small. So now we know that AD is equal to 8, 5 minus 3, 4. What is my final answer, guys? Beautiful. That's it. 5.16. All right. Okay. So I think we're going to stop the lesson there for today because like what we did today, we only did 3 questions, but that was a lot.